to turn this. Perfect. All right, welcome to track one. This is DevSec Defense, how DevOps practices can drive detection development for defenders. I'm really excited about this topic and this presentation. I've been working on it for a few months. This is actually the very first time I've given it, so hopefully we'll all have a lot of fun together. My name is Daniel Bohannon. I work for FireEye. I'm an applied security researcher there. Had some experience with Mandiant doing incident response consulting. And in general, I'm a blue teamer who likes to think really offensively about languages, particularly PowerShell, but also some other ones. I really like writing detection stuff in general. I like catching attackers. I like helping clients and customers, not be blindly hacked, and I really like writing obfuscation stuff. So, what we're going to talk about today, first just kind of the motivation behind this talk, behind kind of the methodologies that I use for creating detections, and then we're going to look at three case studies. One is PowerShell obfuscation, the next is command.exe obfuscation, and then we'll look just kind of at generic framework fuzzing, and I'll explain what that means, and then just some key takeaways. So first, my motivation. What got me started in this? As I said before, I started in IT operations and then got into security through a couple different things. But there's been two real things that have remained consistent across all of these transitions. One is really good coffee. I love coffee. I love everything about it. I love coffee shops. I love all the ways that you can make coffee. And I love the energy that it gives you and the people around you if you share the coffee. And PowerShell. I love PowerShell. PowerShell has helped me automate things even before I got into security, and it's really just made my life several steps happier because of the stuff that you can do with it. Attackers also love PowerShell because it's incredibly powerful. Attackers love it because it's native signed Windows binary, so a lot of security solutions that do out-of-the-box application whitelisting often will allow anything that's signed by Microsoft Run, and PowerShell fits that bill. There's tons of offensive tools that are open source that attackers love to use. It makes their job easier. And one of the main ways that we see attackers for that initial foothold, for the initial attack onto a system or into an environment, typically will use a remote download cradle. Basically just a one-liner to download something and execute it in memory. This uses Invoke Web Request, which is PowerShell 3 or later, so we rarely see it used because attackers like to stay in PowerShell 2. I put new batteries in this thing. I was hoping it would behave a little. Come on now. All right, I'm going to take that out. So attackers typically will stick with PowerShell 2.0, with something like that. So my job is to look at what are the ways that we can detect malicious activity in any language, but when it comes to PowerShell in particular, what are the forensic artifacts that are generated on a system? What are network-based detections? What are host-based detections? What are historic detections versus real-time detections? And it's just a really fascinating realm that I get to kind of play around in every day. And for me, there's a big difference between rigid detections and resilient detections. So rigid detection, some people will generically call this a signature or an indicator of compromise, an IOC. But basically my job is to look at detection ideas, particularly ones that we write, and then figure out how can I break this? Because if I can break it, it's not resilient, and how can I make it more resilient? And as attackers change their TTPs, which stands for their tools, their techniques, and their procedures, what do they use? What do they use it for? How do they operate? As attackers change these things, and as defenders, we have to make sure that we're modifying our detections when necessary to stay up to date with the changes. So, what is this talk? Is it automation? Is it DevOps? And it's so cool, all the things I've learned so far at this conference about like true automation and true DevOps. So, I'm not an automation or DevOps expert by any means, but it's kind of a combination of all these things. It's how I found PowerShell enable me to do my job 100 times better than I could without it. So, we're going to dive into 3 detection research case studies. I'm going to walk through my methodology and some of the modules and things I use for developing detections. And then I'm specifically going to focus on the existing PowerShell frameworks developed by the community that I use that help me to do my job. Sound good? All right. First case study, PowerShell obfuscation. So whenever it comes to detecting a new thing, first we want to make sure that we define the problem. What are we trying to detect? Assess our tools. What do we have at our disposal to detect this? And then develop detections around that. So in this case, PowerShell arguments on the command line, as well as PowerShell scripts, can be obfuscated to evade rigid detections that are looking for very particular strings or commands or things of that nature. And the tools that we're going to look at in particular for this are the abstract syntax tree and PS script analyzer as a way to harness the power of the abstract syntax tree. So if you were at yesterday's talk on Invoke Obfuscation, this section will look a little familiar, but I've added in a couple new things. So again, if we're an attacker and we have this command up here, this remote download cradle, which is running this bit.ly link and the script that resides there, as a defender, maybe we'd write a detection like this right here, and we'd look for if we see a command or a script that has Invoke Expression, new object, net.web client, etc., then we're going to say, hey, this is potentially malicious. I want to know about this. However, attackers can do a lot of things to obfuscate when it comes to PowerShell syntactically. They can concatenate strings. They can interchangeably shift the slashes in URLs for PowerShell. PowerShell is very flexible when it comes to that. When it comes to download string, which is a member, they can put single quotes around it, double quotes. They can also add tick marks. Come on. This is so strange. I've never seen it do this. I know, seriously. It's only on stage, though. Maybe it's the elevation difference. Maybe I should just sit down there. You can put double quotes around members. You can also put tick marks, because a tick mark is the escape character, and if you escape something that doesn't have any escapable meaning, then it still processes just fine. So you can add a lot of tick marks, as long as you don't put it in front of these characters that have special escapable meaning. But if you want to put tick marks there, all you have to do is uppercase them, and it works. You can also put parentheses around your member, and at that point you can truly treat it as a string. So you can concatenate it, and if you're in PowerShell 2, you have to add this .invoke method or member token, but in PowerShell 3 or later it's not necessary. So again, as a defender, I don't want to make that a requirement in my detection because it's not necessary. Other things we could do, we could use the -f format operator to concatenate download string and reorder it and then reassemble it with the format operator. We could do ASCII character conversions. So we have this nice array of ASCII values. We'll do cast them to chars and join it back together, and this is now download string. What is another way that we can produce download string? So in this demo, I'm just kind of walking through my methodology of how I'm going to find a new way to produce the string download string. So if I say new object net.web client, then we saw what happened, but maybe I'm interested in the members. So if I pipe to get member, you actually see conveniently download string is actually present there as one of the names of one of the members. That's cool. Maybe I'll add into the pipeline to say, you know, I'm really interested in this download string. So where the name is like download string, then I would like that. In that case, we got it. And so I'm really interested in the name. So let's wrap it in parentheses, add .name. And now it's producing the string download string. So here's where it gets more fun. We can use wildcards for download string. And something like that will still produce download string without it ever showing up on the command line or in script log logs. Instead of like, we can use I-like or C-like because a lot of people aren't looking for that in detections. For the current variable, we can do a lot of different things like that instead of $_. For where object, we can use the question mark. Get member, anytime you have get dash, you can remove it from the commandlet and PowerShell will still find it just fine. You could also use the alias GM, or you could invoke the object return from get alias for GM, which will also invoke the same thing. So net.web client is an argument of new object, so we could take that and wrap it in parentheses and then concatenate it. And for new object, we could do something very similar. In this case, we'll just use the -f format operator and invoke the reassembled string. Just like that. Now, the important thing here is that as an attacker, I can produce this string without it ever appearing in script block logs or on the command line or anything like that. So now that this is our download string, let's just copy that. And let's reproduce that simple download cradle, right? So invoke expression, new object net.web client .download string. We'll put in that bit.ly link, and it's just going to print a single line in green because I love right host foreground color. It's the best. Although, hold on, let me pause this. Make sure that you check out Stefan's talk on the format subsystem because it freaking blew my mind, and now colors are like just like I have so much to check out. So a really awesome talk. Definitely check it out. So we put a set of parentheses in. We're going to drop in that huge garbled string substitution command, and that payload works. So now download string has been substituted by this crazy, just garbled pipeline of mess. Pretty scary, right? Depending on who you are, I guess. Whew, all right, man. So let's drop that into the command there. We could keep going. We could add just tick marks to that, concatenate the argument. We could use a format operator. When it comes to a new object, we can add tick marks. We can concatenate. We can do the format operator. We can do ASCII characters. We can do get command with wildcards that is going to return new object, and then we'll invoke with a dot or an ampersand. Now, when it comes to Invoke Expression, there's a lot of options here, and to kind of walk through some of them, I'm storing everything into this expression variable just for simplicity's sake. And so we can use Invoke Expression or IEX. We can put tick marks in the commandlet. These will look familiar. We can basically invoke with an invocation operator, concatenation, format operator, ASCII. This one's really fun. It's basically taking a string, in this case an empty string. It's looking at the last index of any. It's casting that whole blob to a string, and then it randomly selects I, E, and X, in this case the 84, 11, and 80th index characters of that. The last option is doing something similar. It's looking at the comspec variable, which is 27 characters long. It's C Windows System 32 command.exe, and 4, 26, and 25 are the characters I, E, and X. Groups that back together and invokes it. You can use get command and get alias with wildcards to produce the returned object and then invoke the object, which is Invoke Expression. You can also use script block creation to cast expressions to script blocks, and you then use invoke command or dot invoke, PowerShell run space, invoke as a workflow, which is PowerShell 3 or later. You can also use PowerShell 1, and I've rarely seen attackers do this just because it's so much easier to write IEX, but you can use invoke command, get commandlets, invoke script. There's tons of things you can do there. And you can use that same substitution syntax, and for every member, every method, just kind of expand it into this crazy mess of parentheses. So, I wrote a tool and released it a year ago called Invoke Crafter, and I built an entire section for invocation options, which is pretty much what we just looked at. So you can very easily go through and just hit a number, and it'll randomly produce this crazy invocation syntax. Come on. It's giving away all my memes. This is really upsetting. Come on, stick with me. Okay. Let's do a demo. So the very first obfuscation framework I put out was Invoke Confiscation, which takes any arbitrary command or script and will obfuscate it. And then Invoke Crafter will take a URL and let you explore different one-liner remote download payloads. So for Invoke Obfuscation, we'll just fire it up really quick. For all my tools, I like to do animated ASCII art, just because it makes life fun and because of colors. So again, for Invoke Confiscation, we can put any script block, any path that we want. So in this case, we're going to set the payload just to be a write host command to keep it simple. We'll look at token layer obfuscation, and what this does is it uses the language parser to go through, and for each token type you select, it will obfuscate it. So for example, we want to look for strings, so we can obfuscate it with concatenation, with format operator. We can go into command and choose option 3, which is going to be reordering. So now that's write host. And again, think about this expanded to crazy big scripts, and I'll go through and do that for all the tokens. Or we can just do option 1, which says do all the tokens in random order, and you can layer that onto itself. So as you can see, the command still works. So let's jump back out and say, okay, at this point, let's treat the whole command as a string, and now let's reverse the whole command and concatenate it. And then let's then reorder that, and you can just add layer upon layer. But man, our command's 2,900 characters. Let's add some compression to get that down a little bit. Boom, knocked off 1,000 characters. Perfect, because we have to stay in the 8,191 character command line argument limit. So boom, there's our payload, and it works. So let's remove all that obfuscation and look at the encoding options. You can do ASCII, bitwise XOR. You could do 100% special characters if you wanted to, and then that's what you get. Pretty crazy, right? Let's copy the clipboard just to prove that it works, and it does. That's nuts. That concept was basically blogged about by a Japanese researcher in 2010. He wrote "Hello World" in special characters. It's insanely cool. A really cool way that he did that. You can also do white space. So white space delimited by tabs, or tabs delimited by white space. So now the whole command is in that huge white space blob, and then it resolves with that stub decoder. So there's a lot of things you can do with this PowerShell. Now, that's Invoke Obfuscation. So let's jump over to Invoke Cradlecrafter and say, you know what? I want to give you a URL, and let's see what kind of crazy remote download cradles that we can get from this tool. So again, more animated ASCII art. So let's set our URL to this bit.ly legit link. And I have it broken up in memory and disk-based cradles, so we'll choose the first one. And it gives you information about the artifacts and the behaviors of the cradle from a defender's perspective, but you can go in and start to modify particular pieces of the command. It's also highlighted very nicely. So you can use get command, get alias, you can use a crazy 1.0 syntax like that, and it's going to be really different every single time, but we can still test it and see, yeah, it successfully downloaded the payload, but it didn't invoke it, because we have a separate menu we can add whatever invocation syntax we want. And so this is from the screenshot we saw earlier. So in this case, I'll just choose option 9, which is, that's now the string IEX. And it's using the verbose preference automatic variable and extracting characters from it. So it successfully ran our command. We can also just go into all, and it will basically choose all these options in random order, and again, look pretty different every single time. So what's neat is we can take this out of Invoke Cradlecrafter, and then we can put it as input into Invoke Obfuscation, and then apply all this token layer, string layer, encoding layer obfuscation. So let's just make sure that I copied and pasted right. All right, it did. So now let's go into token. Let's go to all, obfuscate all the tokens in this command. Perfect. And then let's go back to the string, and we'll just do one layer of string obfuscation. We'll reverse it. Perfect, it reverses. Let's test it. It still runs. So as a defender, why in the world did I do this, right? Like, kind of seems like I'm making life difficult for myself. It's kind of true, actually. Well, I did it because I wanted to know if it's possible, and if it is, then how do we detect it? Because if it's possible, someone else out there is probably already using it. So what tools do we have to detect this kind of stuff? And as a defender, I like to detect things many different ways with many different tools. So only looking at one or two aspects here, but I really like to overthink how to detect this, because when attackers start to change little pieces, I want them to have to change so many pieces to evade all of my detections that we're really likely to see when they change some pieces but not others. And then we get to revisit this and say, okay, how do I need to tune my detections to catch what they're going to do next? So the tools at our disposal, first of all, PowerShell logging. The logs that PowerShell 5 produces are just insanely awesome. So script block, module, transcription logging. The abstract syntax tree and PS script analyzer is really what we're going to look at here. So if you tokenize any given command in PowerShell, it'll say, hey, here's the generic bear word, here's the argument, here's the string, here's the operator, etc. But what's awesome about the abstract syntax tree is it shows you the relationship of all of those tokens. So how can we use the abstract syntax tree? Well, we can use it in Rick Astley memes if we want to, because the AST is conveniently in his name, or we can actually use it a little more intelligently and do cool data science stuff. And this is what Revoke Obfuscation was that I talked about yesterday. And basically it's a data science project that myself and Lee Holmes with Microsoft and one of the original PowerShell developers, we worked on this together last year, and basically used the abstract syntax tree as a way of extracting features, basically extracting thousands of pieces of information from any input command or script, and then using data science and mathematical and statistical analysis techniques to basically say, this is abnormal, this is obfuscated or not obfuscated. So, again, if we look at this example here, and we've obfuscated this download string member, let's say we just look at it simply and say, if we look at this member, then how many of the characters are alphanumeric versus special characters? So here's just a little command to do that, and almost half of the characters in this example are non-alphanumeric. That's really weird, right? But it would be really difficult for us to go through, actually difficult and not really effective for us to say, well, how much is too much? And so instead, if we just extract these features, then we let the data science learning process actually figure out which features are more important than others. So in Revoke Obfuscation, in this case, we're consuming event logs. You could also point it to a directory of scripts, but then we're reassembling the scripts from the script block logs, and then we're piping that into measure Revoke Obfuscation, and we're storing it in a variable called res. So if we run this, it's going through all these reassembled script blocks, extracting 5,000 features from every single one of them, and then measuring them to say this script is obfuscated or not. So if we look at index 4 and look at the script content, then you'll see this is one of those white case encoding examples that we saw. Now what's awesome is that script block logs record every layer of execution, so that's actually the second stage. That's the second layer that is unwrapped, and it detected that as obfuscated as well. And then if you look at all the different objects that come back from this measure obfuscation, you'll see all 5,000 attributes, all the features are there with all of the data. So you really have everything you need to do additional analysis if you'd like to. And it records like the time it took to measure, to determine if it was obfuscated or not, etc. So if you're interested in more of this, Lee and I wrote this white paper. The code is online, and there's also, you can watch me and him kind of jab each other a little bit on stage and talk about some of these techniques as well. I had a lot of fun with Lee on this project. But you can also use the AST for evading detections. So Ryan Cobb, he's a consultant out in Texas for a company called Protivity, and he released this tool called PSAMSI last fall. And so basically, he takes any given antivirus vendor with their signatures, and he basically inspects how it's detecting whether a script is malicious or not. And he uses the abstract syntax tree to basically take every little script block, every piece, and then say, hey, antivirus, do you think this is obfuscated? And if it says, yeah, I think it's obfuscated, then he goes further and says, okay, let me break it out into all of its pieces. Do you think this one's obfuscated? Oh, no? Okay, that's good. Do you think this one's obfuscated? No? Okay. Is this one? Oh, okay. Now I know there's something in here I need to change, so let me break that one out further. And basically, he's able to systematically identify every little piece of the command that is part of a detection in antivirus vendors that are integrated with AMSI. So he can minimally obfuscate a script. And he gave an example of doing this on stage, and the script that he minimally obfuscated actually wasn't detected by Revoke Obfuscation because it fell under the data that Revoke Obfuscation was trained on, which I thought was really clever. It was a really cool idea. So how do we detect minimally obfuscated scripts? Well, this is where PS Script Analyzer is really cool because it makes exploring the AST objects really simple. Now, most people probably use PS Script Analyzer to make sure that code is conforming to best practices, like stylistically and everything like that. But last year, Lee Holmes released a module that actually would say, hey, this is actually some dangerous stuff you're doing here. This might actually allow someone to inject code into what you're writing. So what I did here was I created some rules, and I just published this about an hour ago on my GitHub, and I'll put it up on the PSConf EU GitHub right after this talk as well. But what we're doing is saying, you know what, parse out all the member expressions, like download string, and if any of them ever contain a tick mark, that's really suspicious. I would like to know about it. On top of that, if any of them contain any non-alphanumeric characters, and this actually had some false positives, that's why I'm doing some things like trimming, encapsulating parentheses and quotes and stuff like that, then I would also like to know about it. So this is not using any data science or mathematical techniques. It's actually writing signatures, but the AST allows us to write signatures for very specific components of any command, which is really cool. So I released this module today, PS Script Analyzer Obfuscation Detection Rules, with these six rules in here. And so it's really nice to use it with Invoke Script Analyzer by itself, but when you're dealing with really obfuscated scripts, there's a lot of output. And so I wrote this measure SA for Script Analyzer obfuscation module, which will wrap all of that together and make it a lot easier to view all the results. So, as part of the Revoke Obfuscation research, Lee and I assembled this huge corpus of PowerShell scripts. And then we also generated obfuscated scripts. And so what we're looking at right now is just a random sampling of 30 scripts that were obfuscated with the Invoke Obfuscation framework. And as you can see, it's firing on these like ticks in members, really long member values, non-alphanumeric characters, etc. And another reason for this wrapper is to basically just kind of group by count. We'll see one in a second that's going to be all the special character usages. Yeah, 539 instances of that variable. Like, the output was really ugly, so kind of grouping it makes it a little cleaner to look at. And what's really cool is at the end of all this, we'll group all the different rules that fired and see what rules are most effective at detecting this kind of genre of obfuscation. And so there they are right there. So non-alphanumerics and ticks and members were really good at detecting this. So the next one we'll look at is Invoke Cradlecrafter output. And remember, there's like no tick marks in this, but it's all that crazy like piping of stuff to have this really long pipeline of information that eventually resolves just to a single string. And so as you can see, it's firing on a lot of non-alphanumeric characters and members, and also really long member values. So I'll fast forward just a second here. The third one is looking at ISE steroids, which is so cool to meet Dr. Tobias here, because he wrote it, and that was the original inspiration for any of the obfuscation frameworks I wrote in the first place. So if you're a defender mad at me, I guess you should kind of also be mad at him just a little bit. But you can see it pulled out all of his really interesting special character variables. But then the fourth example, which is running right now, is looking at non-obfuscated scripts. And so it's just marking them as clean, and you can go on. So again, it's just a nice, colorful way to kind of say, hey, how effective are these rules, and what other rules might I want to write against very specific AST objects? And so, I don't know, I found this really interesting as another way to use the power of Script Analyzer and AST to detect things that we've never seen before. All right, PowerShell obfuscation, that's over. We're good. Solved all the world's problems. Boom. I'm a little optimistic. Okay, case study number 2, command obfuscation. So the problem here is that similar to PowerShell, there's a lot of crazy obfuscation you can do for command.exe and its arguments. And the tools that we're going to use here are Pester for unit testing, as well as custom fuzzers, and I'll talk about what that means. So my boss and I wrote this blog post last June about 3 different groups, Fin7, Fin8, which are financial groups, and APT32, which is based out of Vietnam, and some of the really interesting obfuscation techniques they were using in the wild to evade certain detections. And so this one group, Fin7, pulled out this trick, which really blew my mind. This is the screenshot down here is from an obfuscated link file, a malicious link file. And this group was using JavaScript obfuscation for the string eval. They were using this string from char code 101 and concatenating the rest. Thought that was really cool. But these 2 boxes in the red, which is this command.exe command, it didn't make any sense to me. So let's walk through it. Basically, they're setting this wscript command into this process level environment variable x. And then at the end, they're echoing x into command.exe. So another command execution receiving it as standard input. Oh, come on. But they're putting in these garbage delimiters, these @ signs right there. And then when they echo the x variable, they create space after the variable name, and then they put this syntax in there, which is a native command.exe string substitution, which says find every instance of @ and remove it with whatever is on the right side of the equal sign, which in this case is nothing. So it removes @ in memory. This is really cool. And when I saw this, I was like, man, that's insane finesse. Like, how cool is that? But I also had no idea command.exe could do this. And so at that point, this was 10 months ago, so I started a 9-month stretch of research on command.exe obfuscation so that I could figure out how to detect the things that we've never seen used in the wild before. So just last month, I released this white paper on this topic and also this tool called Invoke Confiscation, where you can basically take any arbitrary command and do stuff like that, and it still executes just fine. Unlike my pointer here. Oh, so strange. Come on. Come on. It's ruining all my memes. Don't do this to me. All right, so why did I do this? Well, again, I suffer from FOMO. But as you may have saw a second ago, for me, it's about fear of missing obfuscation. I'm really impressed because maybe it sounds weird, but when I see attackers doing really creative things, then it's interesting. Like, it's creativity that really kind of inspires people. Unfortunately, sometimes that creativity is like in doing crime and seeing people do that, but it still makes you think in a different way. So I like to think differently about it to come up with more effective detections. So, Invoke Obfuscation, I wrote this as a custom fuzzer. Similar with the PowerShell stuff. We've never seen this before, so let me try to understand all the rules that apply to this kind of obfuscation. Let me build it into a tool where I can just pump out thousands and thousands of examples so that I can then test my detections against every one of those examples. So every time I added a new piece of obfuscation, when I found out, oh wow, you can add a comma or a semicolon, anywhere you can use a white space that's used as a delimiter character. That's crazy. Let me spend a weekend adding that into the tool. And then let me run all my pester tests and see, oh, this actually broke this one piece over here. Why? Oh, there's a use case I didn't think about. Let me take that into account. So pester was really cool at helping me make sure my command still ran properly. And it was also neat to test detections in very focused instances. But I still wrote this Invoke DOS test harness to help me better visualize how effective my rules were across thousands and thousands and thousands of obfuscated samples. So let's fire it up. This may surprise you, but animated ASCII art. All right. So just showing a simple echo statement and how you can obfuscate it, in this case using some concatenation and some crazy insertion obfuscation characters. But we're going to set a payload here. In this case, set command. We'll just do another echo statement to keep it simple, relatively speaking. And we'll just do one quick example of going to payload obfuscation using fin coding, which is fin group encoding. And you can just plug in a number for one of these profiles, and it will pump out something like that. And so we can copy this to the clipboard, paste it into a command prompt, and see that it still runs our command just fine. And there's a lot of different ways that you can obfuscate this stuff. Thank you. There was no applause the first time I showed this to some of my people I work with. They thought it was cool when they saw the detections I wrote for it, but initially they were like, dude, what are you doing? So the really cool part here is that you can run pester for all the pester tests I release with this project and test all the individual components of all the functions in here. But I built the tool in such a way that for people that just use the interactive tool, they get a subset of the obfuscation options. But under the hood, there's over 20 different parameters for every single function to randomize everything I could think of. So that's where if you use the test harness here, it will randomize all those parameters every single time, and it will go through all these functions and start generating test payloads. Now what you can do is go into the get DOS detection match. And there's this array here of detection regexes. So what you can do is create rule names and regexes to start to identify the little pieces that are unusual in all this obfuscated code. And this is the exact tool and process I use to build detection for all this research. So after the test harness goes through and generates all of these samples for the 4 main categories of obfuscation in the tool, it will then take them and execute them all to make sure this is still proper syntax, but it'll let me know if this failed to execute, or this executed but it wasn't detected. And what's cool about this is you can then see the rules that matched, how many matched. You can then look at the examples and say, well, why did this match? But more importantly, you can see, why didn't these match? These two were not detected. If an attacker ran these commands, I wouldn't detect it. I removed the rule, so I would detect it. But you can see here, yeah, these two didn't have any detections. Or, hey, this one had 10 detections. We caught it in 10 different places. How cool is that? But maybe there's some that were only caught with 1 rule. Or 2 rules. That's really scary because that means there's only 2 pieces that we caught this on, and if an attacker changes anything about those 2 that doesn't match our rule, then we don't see it. And so it's a really cool way to visualize how close you are at being satisfied with the detections. And I tweeted this out because every night for months I would basically kick off these massive test harnesses with thousands and thousands and thousands of iterations and pray that when I woke up, it would be all green. But it was really cool when it would come back like this. And it's like, hey, 1 out of 1,000 wasn't detected. That's awesome because I get to then go look at that sample and be like, how did I evade my own rules? Because I wasn't able to think about it, but since I put all the logic into the fuzzing framework, it was able to do it for me with all the randomness in the world. Well, all the randomness in GetRandom. But, yeah. So that was command.exe obfuscation. And this really is the reason why I create obfuscation tools, is to be able to do this kind of stuff and let the tools find my mistakes for me. The very last one is framework fuzzing. So basically, any public tool that generates payloads or even obfuscation or anything like that, just like Lee and I created this huge corpus of PowerShell scripts, we can take public code and run it. We can use the tools Control-C to copy and Control-V to paste that sucker into a for loop, and then generate thousands of examples, and then start to wrap a framework around it to say, how do we detect this? So I'm actually going to walk through detecting a component of my own obfuscation tool, because not everyone can spend, this may look out of place to you because measure command doesn't have a months field, but I made one that does because this is how long it took me to do this research, and the whole point is to release this research so people don't have to spend 9 months on it, but that they can start benefiting from it right away. So we can apply these principles to public offensive tradecraft. And this is the, come on, this is the last demo. Keep going, almost there, almost there. All right, so invoke obfuscation. Whenever you do string or encoding obfuscation, it has to put an IEX syntax somewhere. So I went into GitHub and pulled out the lines that contain how that's generated. And I pasted those lines into this for loop. And so it's just adding it to this array. So every iteration of the for loop, we get 6 new samples of obfuscated code. We're going to run this 10 times, and then we're going to unique all the output. And then we're just going to simply output visually. I know it's right host, bear with me, but we're just going to say how many samples were generated and how many were unique. So out of 60 samples, 39 were unique. So let's increase that number. Let's see how many are unique after that. 600 samples, we have 56 that are unique. Let's increase it to 1,000 and see if we get more than 56. In this case, it's still 56. Okay, well maybe 1,000 is enough. And then to kind of reduce that data set a little bit more, let's just remove white space from the commands. So we're going to go from 56 samples, cut it down to 28. Perfect. And now we can actually look at those samples and see these are in the current lines that are in my project on GitHub, these are the obfuscated IEX samples that it will produce. So then what we can do is we can have our regex array and start adding in rules to say, how can we detect all of these pieces? We'll then add all those regex terms to a regex statement, and then we'll check the numbers that are matched versus not matched, and then we'll output the detection rate for this, as well as the regex that we used. So, out of the box, we don't detect anything. Makes sense? Let's go through and let's find one of these to start writing detections for. Let's see, what do we want? Maybe this PS home. It's using the PS home automatic variable, and it'll randomly choose 2 indexes for the letters I and E, and then add X. So, let's start writing a regex here for this. And not that regex is the only way to do this, but it's just a simple way to kind of illustrate the concept, the iterative concept here. So let's just do the 2 concatenations of these PS home values. We'll escape the brackets, the $sign. We'll just say, a 1 to 2 length digit for both of these. And then we'll run it and see what our detection rate is. So we go from 0 to 8. Perfect. 8 of 28 samples were detected. Let's look at what's left. Okay, I don't see any more PS homes, but let's scroll up and, oh, I forgot, yeah. So you can actually, remember how we removed white space? Well, let's make sure that we add that possibility for white space back into the rules that we write. We reduce it just to kind of minimize the data that we're looking at to get ideas over what would detect it. So we're still at 8 of 28, perfect. So then if we look at another sample, we see a very similar one that's using shell ID instead of PS home. So let's just make that a rule. And you could put it in the same regex line. I prefer to keep them separate just for some different reasons down the road, but we'll replace it with shell ID, and we went from 8 detections to 10 detections. And I just keep going through this iterative approach until that detection rate is 100%. For kind of a first stab at detecting it this way. So I'm going to uncomment this block, which contains some more of the rules that I wrote earlier on to detect all this. So let's uncomment that. Since we just created the PS home and shell ID, I'm going to comment the 2 existing ones out. We're going to run it, 100% detection. So again, the methodology is generating sample data and then iterating through and testing your detection ideas to see what kind of rates you're getting. All right, key takeaways. Sometimes as defenders, we might say, man, like, what are we going to do with this? Like, you really expect us to spend all this time trying to detect this undetectable stuff. And at the end of the day, ignorance does not equal bliss. It may at some point until you realize that you're compromised, and then it's not fun and games at all. So I think it's important as defenders for us to think offensively to better understand what attackers are doing, because we get to see that, but also what is possible for an attacker to do, even if we've never seen it before. And we as defenders actually have a role in shaping the way that attackers act in some regard. And we just have to keep in mind what's the landscape, what are the tools that are available for attackers to use as well, and how might that shape their activity. They could run any command in the world, but if there's tools that are very enticing to them to run to detect a lot of simple evasions, then maybe they actually bring their behavior down to a smaller pipeline. And we want to get really good at detecting anything in that smaller pipeline. So that's kind of what I mean by shaping attacker activity. Where do you start with this? Where do you start with these detections? Well, as you saw, I started with 0% detection. I just gathered the data and then wrote a simple way to iterate through, and then said, let me start with anything. I don't know. Let me start detecting the bad that I know, and then let me apply that to all the data that contains a lot of good as well, and see how many mistakes I'm making, to see how often does my detection say, this is bad, but it's actually good. And that just comes from trial and error. And we have to make sure that we are okay with making mistakes, because we have to start somewhere. And we all make mistakes, and we're continually improving and tuning the detections that we have, just like you're continually tuning and improving the performance of your modules and things like that. And I also think that it's important to, the second point here, to automate testing to preserve brain cycles. Now, I'm a nut about this. Tester testing is amazing for this, because basically if I have to look at output and then in my brain say, did it match these rules, that's stealing energy from creativity that I could be doing. So if I can put that into a pester test, all of a sudden, I never have to think about that thing until it shows up not green when I run invoke pester. That's beautiful. That means I get to automatically do all the stuff I've thought about once and thought about it enough to code it, and then I get to use my brain cycles just for thinking about new ways of detecting what's left. And I also think it's important to share successes of what's worked as well as failures, because we can learn so much through failures of different approaches and different techniques, and everyone's environment is very different. So what doesn't work for me in my environment may be a perfect solution for you in your environment. And if we don't talk about those things, then we're potentially stealing those opportunities from other people from things that we've learned. So in summary, detection development is both an art and a science. There's a lot of ways to do this, and that's what's really cool about, like, when I talk to people who work for different companies, even those that are technically competitors, like, the way they do things are different than we do sometimes, and that's really cool. And that makes it harder for an attacker to figure out all the ways that everyone is doing detection development. DevSec principles empower more effective detection R&D. And again, I'm not this DevSec expert by any means at all, but it's really cool to interact with all of you and the community to see, hey, like, what are the things that are helping you in your job, and how can I take that and use that to help me at mine? The PowerShell tooling, like PS Script Analyzer, the insanely easy accessibility of the abstract syntax tree, pester testing, and just PowerShell for being able to produce these kinds of fuzzing frameworks is just really cool. And I seriously couldn't do what I do without it. And yeah, just the point about automating what you think about once so you don't have to think about it again. Also, assembling data is really important. So if we're trying to detect known bad thing A, B, or C, how do we get samples of that? How can we leverage public repositories? How can we leverage relationships with people in the industry to get those samples? And then when we don't have enough, how can we generate our own to supplement that? And that's where it takes a little bit of patience to make sure you have the right data in the first place before you really start investing time in creating detections. Lastly, the techniques I talked about are actually tool and language agnostic. I'm a PowerShell fanboy, so I use PowerShell to create the tooling for all this stuff. And initially, I used PowerShell to learn how to detect PowerShell. But you can actually use it to do a lot of different things. The command.exe obfuscation we looked at, I'm using PowerShell to generate non-PowerShell data. And then I'm using PowerShell to create regular expression detections that I then plug into completely different tools. I put them into IOCs, indicators of compromise. I put them into Yarrow rules, all these different detection mechanisms. So again, DevSec defense and the modules that I walk through and the sample scripts that I walk through in the video, they're up on my GitHub, and I'll put them up on the PSConf GitHub as well. Here's some URLs to some of the frameworks I mentioned. And for any of the white papers or blog posts, you can find links to those on my blog under the publications tab. And I really want to say a special thank you to the PowerShell community, because again, it's so cool that like PS Script Analyzer and AST and Pester, like I had no idea how many of the tools I used every day were written by the community. And so I just want to give you a hand for making that possible. And not only in the sharing of tools, but in venues like this where we actually get to share ideas. I've never learned so much from a conference from the attendees than I have from the few days here. And so I just want to say thank you just for the openness and the willingness to share ideas and to help us improve, because it's really a very unique thing. It's really, really cool. So with that, I just want to say a huge thank you for your time. And before I ask for any questions, here's my contact information. I'll be around all day today and tomorrow. I'd love to say hello. And again, thank you for your time and attention. Are there any questions? Oh, okay, let's start right here. Yeah, so for the Revoke Obfuscation, Lee Holmes and I wrote a white paper on that, particularly for using the data science stuff. When it comes to the script analyzer and for the stuff I just showed, this is actually my first attempt at putting that together and kind of sharing it in this format. So there's not a blog post or white paper on that, but there's a Twitter handle, and you can DM me or email, and I'd love to chat about that. But yeah. Say what? And I'm going to write a blog post anyway. Apparently, I'm going to write a blog post anyway, so. Nothing like peer pressure. I love it. Thank you, Rob. Is there another question in the back? Yes. So the question was, when PowerShell downgrade attacks, you won't find script locks and module logs and things in the logs because it's using the PowerShell 2 engine. Was your question, do we find evidence of that, or what do you do in that situation? Mm-hmm. Yes, that's correct. So for a PowerShell downgrade attack, basically, even if you have PowerShell 5 on a system, and if you haven't uninstalled PowerShell 2, then an attacker could simply say PowerShell tac v2 and run their code out of a PowerShell version 2 engine. And in that case, you won't get module logs or script lock logs or transcription logs, I don't believe, because it's not a feature in the PowerShell version 2 engine. Lee Holmes actually wrote a really good blog post specifically on detecting PowerShell downgrade attacks. And one of the things you can do is in the PowerShell event logs, you can look for mismatches between the engine version and the host version values. I would say, and this is something that we look for when we do incident response, but there are definitely legitimate applications out there that will specifically downgrade typically to version 3. So you will see some legitimate mismatches, but you can always look in the host application field and then potentially whitelist on that value depending on your environment. But yeah, that is one way that you can do that. And the recommendation is uninstall PowerShell 2 if there's some fringe cases in which you can't do that, but if you can, that's definitely the recommendation. But really good question. Thank you. Does that answer the question? Okay, awesome. Thank you. Any other questions? No? Awesome. Well, again, if you have any questions, please find me outside, and thank you again for your time.